Good morning, students. I am Dr. Sunil Kumar Bhatta. So, in this video lecture series, today I am going to explain the topic phase control rectifier from the subject power electronics and PLC. So, before starting the phase control rectifier, the outlines of my presentation are the phase control rectifier. So, we'll know about what is phase control rectifier. Then we'll go to what are the types of phase control rectifier, what are the classification of phase control rectifier. Then in the classification, the types is half wave and full wave rectifier. So in the details with R load, I am going to explain you about the half wave rectifier and full wave rectifier. So before starting the phase control rectifier, so let us just recall what is power electronics, because it is a very important subject of electrical branch. So what is power electronics? Power electronics is a branch of electrical engineering which basically deals with the conversion and control of electrical power by using electronic devices. So that is called power electronics. Now, what is the benefit of power electronics? What is the advantage of power electronics? So, power electronics basically enables us to use the electrical energy in an efficient manner. In an efficient manner means the according to the voltage level we can use the voltage. So, the voltage level can be managed by this power electronics, and this power electronics can be used in various industry, in the household application also we can use. So in the different manner this power electronics can be used. Now coming to phase control rectifier. So what is phase control rectifier? So as the rectifier word is there, so that means rectifier, we know that rectifier means which converts AC to DC. AC means alternating current, DC means direct current. So phase control rectifier, so which converts AC to DC. So that is called the phase control rectifier. So in the phase control rectifier, basically we are using the thyristor. So thyristor that belongs to the ACR family. ACR is called silicon control rectifier. So here the thyristor that is used in the rectifier. So what is the advantage of using thyristor? So when thyristor is used in the rectifier, then the output voltage, we can say the output voltage is control voltage. The voltage can be controlled. One is uncontrolled voltage, one is controlled voltage. So when I say about control voltage, that means the thyristor that is used. When I say uncontrolled voltage, so that means the diode is used. So that is the difference between control voltage and uncontrolled voltage. So in the phase control rectifier, the control voltage can be obtained. So by using thyristor, thyristor will give us a control voltage. And how thyristor will give control voltage? By the firing angle, by the delay angle, that is called alpha. So by adjusting this angle alpha, we can get the control output voltage. So the output voltage is a DC voltage because it is a rectifier. So the DC voltage can be controlled by adjusting the firing angle in the thyristor. So this is the control voltage and uncontrolled voltage that is also mentioned here. The diodes offer no control over the output voltage, so it is called uncontrolled rectifier. So now the application of phase control rectifier, as I said, it can be used in the different manner. So in the different industry purpose also we can use. The industry that we can use here: HVDC, electric traction, steel mill, paper mill, textile mill, where the speed control of DC motor are necessary. So by the controlling the DC motor, and how this control is possible? By this power electronics or this phase control rectifier. So that is the main application of phase control rectifier. Now coming to the next slide. So in the next slide, so here the classification, the types, what are the types of phase control rectifier? The types is basically single phase and three phase. If it is a single phase supply is there, so single phase rectifier. If it is a three phase supply is there, so that is a three phase rectifier. So in the single phase and three phase, you can see the HWR, FWR. So that is half wave rectifier and full wave rectifier. So single phase supply, single phase rectifier, so that is divided into two types. One is half wave rectifier, second is full wave rectifier. And also in the three phase, in the similar manner, half wave rectifier and three phase full wave rectifier. So the full wave rectifier, you can see it is again divided into two types. One is full converter and semi converter. Full wave converter, semi converter. Okay, full converter. Full converter means when four thyristors are used, that is called full wave rectifier, full converter. And the semi converter, so when thyristor and diode both are used, so that is called semi converter. So these are the classification of phase control rectifier. Now coming to the single phase half wave rectifier with R load. So in the classification, as I said, it is a half wave full wave. So in the we'll discuss about the half wave rectifier first, then we'll move to full wave rectifier. So in the half wave rectifier, half wave, you understood the meaning from the title, single phase half wave rectifier. So half wave, only in the half, in the positive half, we are getting the voltage. We will get the voltage in the positive half. In our supply system, in our AC supply, there are two half, one is positive half, negative half. So the output voltage what we are getting in this half wave rectifier, so only in the half wave, in the positive half, in the negative half there will be no voltage. So that's why the name is called half wave. So here single phase half wave control rectifier, as the name suggests, it is a rectifier which converts AC to DC only for positive half cycle of the AC input supply. So in the negative half cycle there is no voltage. So here you can see in the circuit diagram, in the diagram the transformer that is connected, the input voltage is connected through the transformer, thyristor is connected in series with the resistor. What is the use of transformer here? The transformer will give the voltage level, the voltage according to the voltage requirement, the transformer can maintain that voltage level. So that's why the transformer that is connected here. So here the transformer is used only at the supply side in order to change the voltage level according to our requirement. Okay, and the thyristor is connected, and the load here, it is resistive load, it is a purely resistive load is connected. So that is the circuit diagram here you see. So in the circuit diagram, after the circuit diagram, you see next the operation. So basically in the phase control rectifier there are two modes of operation, mode 1 and mode 2. There are two modes of operation, that is mode 1 and mode 2. So first mode 1 is for the positive half cycle, mode 2 is for the negative half cycle. So in the input AC cycle there are two cycles, one is positive half cycle, second is negative half cycle. So in the positive half cycle, so that is the mode 1. So in the mode 1, so during the positive half cycle of input voltage, the thyristor that will conduct. When thyristor will conduct, that is a question. Thyristor conducts when anode is positive, cathode is negative. So during that time the thyristor that is forward biased. So here the thyristor that will conduct in the mode 1. Mode 1 means the positive half cycle. So you see in the first, you see the waveform. In the waveform diagram, you see this is the Vs, that is the supply voltage, and this Ig is the gate pulse, gate current that is shown here, and output voltage that is also shown here. So as the input is AC, so you can see that that is a sinusoidal AC waveform that is drawn here. And as I said, the phase control rectifier uses your thyristor, so that we are getting control output voltage. So how control output voltage we are getting? By adjusting the firing angle, by using the firing angle of thyristor. So here the firing angle, you can see the alpha is shown here. So when during the time of alpha, Alpha means the angle at which thyristor is turned on, that is called firing angle. So here you see, from the alpha to pi, so that is the positive half cycle. In the positive half cycle, the alpha at an angle alpha, the thyristor is turned on. So when thyristor is turned on, so from that point to pi, so we are getting the output voltage. So here the output voltage is obtained and the output voltage is positive. Here the output voltage is positive, and from pi to 2 pi, that is called negative half cycle. That is called negative half cycle. So 0 to pi, that is positive half cycle, pi to 2 pi, that is negative half cycle. So here you see mode 2. So mode 1 completed. So mode 2 during the second operation, mode 2 operation. So mode 2, what will happen? The thyristor will not conduct. Thyristor will not conduct. Why? Because the thyristor is reverse biased. During this time, thyristor is reverse biased, so it doesn't conduct. So during that time, you can see in the waveform, so there is no output voltage. There is from pi to 2 pi, that is called negative half cycle. So in the pi to 2 pi, as it is negative half cycle, so in the negative half cycle, there is no output. The output voltage is 0. And again you see from 2 pi to 3 pi, so that is again the positive half cycle starts. So in this cycle also we are getting the output voltage from 2 pi plus alpha to 3 pi. So again in the positive half cycle we are getting, but in the negative half cycle there is no output voltage. Why? Because thyristor is not conducting. Why thyristor is not conducting? Because thyristor is reversed biased. So that is the single phase half wave rectifier with R load. So that is the circuit operation I told you, and the waveform, how to draw the waveform, that operation, that diagram, that is I explained you. Now you see the output voltage. So what is the output voltage formula? So the output voltage is here, the DC voltage. So VDC equals to V maximum by 2 pi 1 plus cos alpha. 1 plus cos alpha. So that is from alpha to pi and from pi to 2 pi. So that is our input AC cycle, AC voltage. So from alpha to pi is conducting, so pi to 2 pi is not conducting, so that's why it is 0. So finally the voltage we are getting V maximum by 2 pi 1 plus cos alpha. What is alpha? Alpha is called firing angle. So that is the VDC, the DC output voltage. And again the average load current or DC current. What is the DC current? IDC equal to VDC by R, V maximum by 2 pi R 1 plus cos alpha. So this is the output voltage formula and output current formula. Now coming to single phase full wave control converter with R load. Again after half wave, the full wave. So as I said, the full wave rectifier means it uses 4 thyristors. So in the diagram first you see T1, T2, T3, T4, 4 thyristors are connected in a bridge manner, and again the resistance is connected. The resistance is a purely resistive load. V0, that is the V0 is written for the output voltage, and the input voltage Vs, that is written in the diagram. So here again shows, the figure shows the typical circuit diagram of a single phase fully controlled bridge converter. It consists of thyristor T1 to T4. They are connected in a bridge configuration during the resistive driving the resistive load. So here this is the waveform diagram. So again in the waveform diagram you can see, you can observe here in the half wave there was no voltage. There was no voltage in the negative half cycle. But you see in the negative half cycle means pi to 2 pi. So first you see pi to 2 pi the voltage we are getting. In the positive half cycle we are getting, and in the negative half cycle also we are getting. So that means in both the cycle we are getting the output voltage. So that is called full wave rectifier. So here you see in the waveform diagram, input voltage Vs is shown here, V0 is shown here, I0 is shown here. So Vs means it is AC voltage. So sinusoidal waveform, that is shown here from 0 to pi, pi to 2 pi, up to 3 pi, that is shown here. So now coming to the mode of operation. So like your half wave rectifier, there are 2 modes of operation.
So here mode 1 and mode 2. Mode 1 is from alpha to pi. Alpha to pi, that is mode 1, and mode 2, that is pi plus alpha to 2 pi. So first mode 1. So what is mode 1 operation? So mode 1 means, as I said, during the positive half cycle. So during the positive half cycle, the thyristor T1 and T2 will conduct. So you see in the diagram, T1 and T2. T1 and T2, they will conduct from alpha to pi or during the positive half cycle, and T3 T4 that will not conduct. Why? Because T3 T4 will be reverse bias. T1 T2 is forward biased, T3 T4 is reverse bias. Reverse bias means thyristor is not conducting, so only will get the output voltage through T1 and T2. So the supply voltage is connected, so from T1 to the current will flow to the resistive load, and through the load, then again T2, then again it will back to the supply. So that is the T1 and T2 is conducting in mode 1. So in mode 1 operation, you see the mode 1 will start from at an angle, firing angle alpha. So from alpha to pi, so T1 T2 is conducting, we are getting the output voltage, and the output voltage is positive. And here the load current is also shown, output current is shown here, the output current is also shown here, and you can see here it is written T1 and T2 conducts. So T1 T2 is conducting, T3 T4 is not conducting because it is reverse bias. So that is a mode 1 operation. So now you see mode 2. So during the time mode 2 starts, it will start from pi plus alpha to 2 pi. At pi, the both the thyristor will turn off. At pi, okay, so at pi thyristor T1 T2 will turn off, and at an angle pi plus alpha, so to 2 pi, so at an angle pi plus alpha, the T3 T4 will start. T3 T4 will conduct, so that is in the mode 2, and T1 T2 will be reverse biased. So during this time also, the both the input output voltage and current are positive in this cycle. So the load voltage is positive with regard to the ground throughout both the cycle. So here in the waveform diagram, again you see, so from pi alpha to pi, so T1 T2 conducting, and pi plus alpha to 2 pi, T3 T4 is conducting. Again the cycle that will continues. And you see in the output voltage formula, so VDC formula, the output voltage VDC equal to Vm by pi 1 plus cos alpha. Alpha is called firing angle or delay angle. And the maximum value of VDC, the output voltage, when it will be maximum? Because when alpha equal to 0 degree, when the alpha value equal to 0 degree, alpha is called firing angle. So when the firing angle value equal to 0 degree, so that time the maximum value, the output voltage can be maximum. So the maximum voltage formula will be VDC by R. Then the single phase half control rectifier RMS voltage. What is the RMS voltage? The RMS voltage VRMS equals to Vm by root over of 2 pi root over of 1 minus alpha plus sine 2 alpha by 2, and the IRMS equals to VRMS by R. So in this topic today we discussed about the half wave rectifier as well as full wave rectifier with R load. So the observation is that in the half wave only we are getting the in the positive half we are getting the voltage, and in full wave in both the half we are getting the voltage. Thank you.